Hey, welcome. So today we are going to break down asthma. For millions of people, it's just a part of daily life. But have you ever wondered what's really going on inside your lungs when an asthma attack actually hits? Well, let's get right into it. So that's the big question we're tackling today. We're going to look at what an attack actually feels like, from the inside out. Then we'll zoom in on what's physically happening in your airways. And the coolest part? We'll see how understanding all that science is the key to why the treatments actually work. All right, so before we get all scientific and dive into the biology, let's just start with the human side of things. What does an asthma attack actually feel like? This quote, it's just a perfect way to describe something called hyperinflation. See, during an attack, it's actually incredibly hard to breathe out. Not in, but out. And that means old, stale air gets trapped inside, leaving your lungs way too full. So that feeling, that awful feeling of not being able to get a good deep breath in, well, it's because your lungs are already packed with air they just can't get rid of. And, this whole internal struggle is what causes all those classic symptoms we hear about. That shortness of breath, doctors have a fancy word for it, dyspnea. Then there's that wheezing sound as air tries to squeeze through those tiny passages. And of course, the coughing and that feeling of tightness in your chest. Think of them like alarm bells, all ringing to tell you there's a serious battle going on inside. Okay, so what is that internal battle exactly? Let's zoom right in. We're going to go from the symptoms you can feel on the outside to the microscopic stuff happening deep inside your lungs. If you boil it all down, the entire problem with asthma is one thing: airway obstruction. It just means the tubes that carry air are getting blocked up. And like we just talked about, this makes breathing out way harder than breathing in. That's what leads to that whole air trapping thing we mentioned and that awful feeling of being overfull. So what's causing this obstruction? Well, it's a triple threat. I like to call it the villainous trio. Okay, so first, the walls of your airways get all inflamed and swollen. Second, your body starts making way too much mucus, which starts clogging everything up. And third, these tiny little muscles that are wrapped around your airways, they just squeeze down super tight. That squeezing, it's called bronchoconstriction. It's basically a three-pronged attack that chokes the airway from the inside out. And the difference here is just dramatic. A healthy airway, it's like a wide-open, 5-lane highway for air. No problem. But during an attack, that villainous trio, the swelling, the mucus, the squeezing muscles, it turns that highway into a congested, single-lane tunnel during rush hour. Okay, so now we know what's happening inside the airways. But the next big question is, why? Why does the body launch this self-sabotaging attack on itself? What is setting off this huge overreaction? Well, the answer really comes down to triggers. For someone with asthma, their airways are just hypersensitive. They react to things that wouldn't bother other people at all. We're talking about common stuff like allergens, pollen, dust mites, or just a simple cold virus. Even something like exercise or a jog in cold air can be the tiny spark that lights this huge inflammatory fire. So here's the chain reaction. When a person with asthma runs into one of those triggers, their immune system basically sounds a false alarm. It just freaks out and releases a flood of chemical messengers. You might have heard of some of them, like histamines and leukotrienes. These are the chemicals that send the signal to the airways to go into full-on defense mode. And what does that mean? It means activating that villainous trio we just talked about. The body is pretty much overreacting, attacking something totally harmless as if it were a life-threatening danger. So with all this complicated stuff happening on the inside, how did doctors know for sure that it's asthma? Well, they have tests that can precisely measure the physical effects of that airway blockage. These tests give them cold, hard proof of what's going on. The main one is called spirometry. It's actually pretty simple. It just measures how much air you can breathe out and how fast you can do it. With asthma, of course, that airflow is blocked. But here's the real key. The magic trick, really? It's called the reversibility test. So after they measure your breathing, they'll give you a puff of a reliever medicine. And if, all of a sudden, you can breathe out way more easily, boom, that proves the obstruction is reversible. And that, right there, is the classic sign of asthma. And this brings us right back to the beginning. Now that we get the feeling, the mechanics, and the triggers, we can finally see exactly how the treatments are designed to fight back. It all makes sense now. See, the strategy behind modern asthma treatment is super specific. It's not just about covering up the symptoms. No, it's about directly fighting back against that villainous trio we keep talking about: the swelling, the mucus, and that muscle squeezing. And this is where it all just clicks into place. You've got the immediate problem, right? The muscle squeezing. For that, you've got something called bronchodilators. These are your reliever or rescue inhalers. They work almost instantly to relax those muscles and open up the airways. But then you've got the long-term problem, the swelling and inflammation. For that, you use corticosteroids. These are your controller or preventer inhalers, and their job is to work overtime to calm that immune system down and get rid of that underlying swelling. So, you can see it's really a two-pronged attack. The relievers, they're like the firefighters. They rush in to put out the immediate fire of an attack, opening up your airways right now. But the controllers, they're more like the fire inspectors. They work in the background every single day to reduce the inflammation and just prevent the fires from even starting. And that's so crucial to understand. The fire inspectors only work if they're on the job every day, even when you feel totally fine. So there you have it. Asthma is definitely complex, right? It involves our genes, our environments, our whole immune system. But by breaking down the why behind it all, from that feeling of a tight chest all the way to the science behind an inhaler, I think we're left with a really interesting question. Does really understanding the mechanics of our own bodies give us the power to manage them better? Something to think about. Thanks so much for joining me for this explain.